Hi everyone. Coming to the topic of the day, API 600. You all understand, people familiar with the value industries are aware that the whole industry is controlled, governed by the codes and standards. Okay, there are standards committees like ASME, ASTM, API, ISO, BS, DIN, who regulates the valve manufacturing and application and the usage. So there are product standards released by various committees. So we are going to talk about API 600. API stands for American Petroleum Institute. It releases a lot of product standards, releases testing standards and qualification standards. It is very important for all of us involved in the valve in some form or other to have a good command on the standard. What we're going to see in this session, next 45 minutes, is going to see a product presentation on gate valve in conjunction with API 600 and see how the standard mandates certain requirements for design, manufacture, inspection, testing, marking, and up to the end stage of packaging. If you want to have a command on any subject, it is important that you need to have the understanding of the codes and standard governed by the subject. So it is important that everyone understand the intent of the standard. You will be able to appreciate the features. Basically, gate valves can be classified broadly as bolted bonnet and pressure seal design based on the construction of the body bonnet joint. As the name implies, bolted bonnet, the connection between the body and the bonnet is flange, which is bolted by means of a fully threaded strap. And of course, you have a gasket. This design is called bolted bonnet. On the other hand, you will find the pressure seal design, which employs the internal pressure to seal the gasket and provides a sealing to the atmosphere. And this joint, this pressure seal design, you will not find any joint, flange joint like what you see in the bolted bonnet. It is quite compact, and this is popular in larger sizes. So this is a two broad category. And what we are going to see is API 600, which talks about sizes 1/2 inch to 42 inch. There is another API standard called API 602, which basically cater compact small size valves, 1/2 inch to 4 inch, and class 150 to 1500. There is yet another API standard 603, which is again going to talk about 1/2 inch to 24 inch and specifically for stainless steel material of construction. So our discussion is going to be more confined to the API 600. See, the current standard for API 600 is 13th edition. It will be issued in Jan 2015. 14th edition under is balloting, and it is expected in this year. And as I told you, this standard is applicable for bolted bonnet gate valves. And this standard provides guidelines related to design, material selection, testing and examination, marking and preparation for shipment. So this is the entire standard, and let's see how the product features are covered, dictated by the standard. Typically, the applications of the API 600 gate valves, as the name implies, it's basically designed for the refineries and petrochemical industries. And of course, you will find application in power plants, water industries, other process industry. By and large, gate valve is one of the most popular valve used in the industry. This is just a typical gate valve cross section. Basically, a gate valve is a linear motion valve where the wedge moves perpendicular to the flow to start or stop the fluid. And you have the body and bonnet, which forms the pressure containing part. You have the disc, which is the wedge, and the seat rings, tapered seat ring and tapered wedge, which forms the heart of the valve, which provides the sealing. And the connection between the body and the bonnet is flanged and through the bolts. And of course, to have a leakage, to prevent the leakage to the atmosphere, you need to have a gasket. Okay, so this is a flange joint with a gasket. And you have a stem which helps to move the disc up and down to open and close. And we have a stuffing box arrangement which provides a system of packing to prevent leakage to the atmosphere. And you have the operator at the top. This is basically a construction of a gate valve. And this gate valve is best suited for on-off application, either fully open or fully closed. It is not suitable for intermediate positions or for any throttling. The reason being, when the disc is lifted off from its closed position, it is unsupported. And due to the flow, the disc, unsupported disc will have a chattering, and this will cause internal damage to the system and other components. Hence, it is not recommended for throttling, though some people in the power industries use it for engine duty for a short period of time. It's a bidirectional valve and purely metal seated valve, so it's suitable for a high pressure, high temperature application. The disadvantage is that it is slow acting, and if you see the stroke length required to open the valve is equivalent to the bore size. Hence, it is a slow acting and it cannot be used where you need to have a fast action. And it is also bulkier and requires a lot of headroom. Nevertheless, since it is offer a metal to metal seated, since it offers a tight shut off, it's best suited as a on-off valve and very popularly used in the refinery applications. Typical constructions is there. We'll see the features of this vis-a-vis the clauses covered in the API standard. So basically, this is the stuffing box arrangement. You have this bonnet bush or back seat arrangement here. And what you see here is the stem wedge connection. Let's see the details in the coming slides. Basically, this standard API 600 will cross-refer to several standards. Though it talks about design manufacture, it does refer to another standard B16.10 for face-to-face. It refers to standard 16.5 and 16.47 for the end flanges, 16.25 for the butt weld ends, and API 598 or ISO 5208 for pressure testing. Let's start the session with the overview of the standards. Any standard, whether it is a product standard or a qualification standard or testing standard, the most important clause is the scope. The scope of the standard will define what that particular standard is for. And it also defines what all applicable in that standard. So if you take the API 600 standard scope, it says very clearly the standard specify requirements for heavy duty series bolted bonnet steel gate valves for petroleum refinery and related applications where corrosion, erosion, and other service conditions would indicate a need for full port opening, heavy valve sections, and large diameter. This is the scope. In the scope, it also covers what size range it is talking about it. In this standard, it talks about size from NPS 1 inch to NPS 42 inch. And pressure classes starting from class 150 to 2500 class. This standard also talks about what type of gate valves are covered. So it says it covers bolted bonnet, it covers outside screw and yoke arrangement, rising stems, non-rising hand wheels, a single or double gate, wedge or parallel seating, metallic seating surfaces. There is no soft seating. It doesn't cover soft seated, flanged or buttoned. So these are the types around which the standard is evolved. Now let's understand what are these terminology. We spent some time on the bolted bonnet, so I'm not going to take you through that. Outside screw, as the name implies, the screw is outside, and you will find that non-rising. And when you rotate the hand wheel, the stem is rising and the hand wheel is non-rising. Okay, this is called outside screw, non-rising hand wheel. On the other hand, you will find a screw inside, and both the stem as well as the hand wheel are non-rising in this case. Okay, so this is basically inside screw. Then the standard talks about the bolted bonnet and the pressure seal design. So we discussed about the bolted and pressure seal very briefly. Pressure seal design is where you will find that line pressure is utilized to create a tight body bonnet seal. You will find a graphite gasket which is compressed between the retainer ring and the bonnet, which provides the sealing. Higher the pressure, higher the sealing. This is popular in high pressure classes. And of course, the API 600 10th edition covered the pressure seal design. But now there is another standard which talks about the pressure seal design, and it is outside the scope of API 600. Then the standard also talks about different types of gates that can be used in this. It talks about solid wedge, it could be a flexible wedge, parallel slide, and different designs. So we'll talk about in detail when we see the clause on disc. The standard also refers to ASME B16.34 for pressure temperature ratings. So all the class ratings are covered by this particular standard. This standard also talks about the wall thickness for different pressure classes. It also talks about the what class flanges, end flanges should be there, what class rating end flanges should be there. There are two classes are available for use in API 600. One is the standard class, another is the special class. The special class allows you to use a slightly higher pressure for a given temperature. And this is possible when you do a certain ND on the body. So which will help you to use a higher pressure classes. The class 5 in the API 600 talks about the design of body, bonnet, and disc, everything. So in this case, the 5.1.1 talks about the body wall thickness. So in any pressure containing part, wall thickness is very important, and all the product standards regulate the wall thickness based on their own experience and based on the allowances required. So now this standard covers the wall thickness for different sizes, different classes in the table 1. So one has to select a minimum wall thickness from this and add to it additional based on their process requirement. Okay, and the standard is also very clear. Additional metal thickness needed for assembly stresses, stress concentrations, shapes other than circular shall be determined by individual manufacturer, since these are all varying factors. So the standard says when you are going to use an oval-shaped bonnet, then you cannot use the minimum wall thickness. You need to have an additional factor to contain the deflection. So the standard is very clear and talks about all these requirements. The class 150, the oval-shaped bonnet will be applicable for class 150 because the face-to-face should be shorter. So you cannot have a circular flanges which will actually protrude the face-to-face. So generally, standard says that the class 150 valve shall have a oval-shaped body bonnet joint. All other classes will have a circular joint. Now let's talk about the wall thickness comparison between the various standards. So we saw API 600 standard, table 1 gives a minimum wall thickness. For example, if you take a 10-inch valve or DN 250 mm for a class 300, the standard API 600 says the minimum wall thickness should be 19.1 millimeter. ASME 16.34 also gives a wall thickness for a different inside diameter. For a 250 millimeter, it gives around 12.8 millimeter. Okay, and I've just compared the various wall thickness here, and I've also taken wall thickness calculation as per ASME section 8, which is for the pressure vessel. So if I had to treat the wall body as a circular vessel and calculate what is the wall thickness for a given material, I'll arrive at 7.2. Whereas 16.34 gives 12.8 and API 600 gives 19.1 millimeter. Thus, you will see that API 600 wall thickness is almost 150% of the 16.34. And again, 16.34, you will find that again, it is almost double that of, or 90% more than the ASME. Why this additional thickness is given by API 600? Because to take care of the corrosion effects of the refinery. API talks about different materials, starting from carbon steel to alloy steel, stainless steel. So carbon steel materials need to have some sort of corrosion allowance, whereas stainless steel doesn't need. But nevertheless, since the standard talks about all the material, it has a safety factor that gives a higher wall thickness. In fact, the pressure vessel code, if you do the calculation, 7.2 is required, sufficient for withstanding the pressure of class 150, which is 285 psi. Okay, so one need to recognize these things when you are specifying sometimes a corrosion allowance in the order. Sometimes you have to reconcile the fact that standard has got a higher factor of safety. There's no point in adding additional corrosion allowance, and thereby you're increasing the cost of the product. The 5.3 talks about dimensions. It talks about the various dimensions. Face to face, we saw it. Here we see that the standard talks about flange, end flange, what should be the standard followed. 16.5 covers up to 24 inches and 16.47 for larger than 24 inches. There is a series A and series B. The difference is on the compactness, AC. This thickness will be less and OD will be less. This is selected by the end user while ordering the valve. And similarly, there are different configurations available. It could be a flat face, or it could be a raised face, or it could have a socket where you have a ring type joint can be used. It depends on the application and depends on the pressure, media. One would specify the requirement of the end connection. And when it is the butt end valves, then there is a standard 16.25 which governs, and it talks about edge preparation based on a different pipe thickness onto which the valve is going to be welded. So typically all will have a sort of a root face onto which a sort of a root penetration welding will be done. There will be a bevel on the flange end as well as the pipe end, and you will find that a weld is a root penetration weld, and which gives a sort of a leak tightness. The standard also talks about the seat bore. Seat bore is a very important dimension around which the entire valve is evolved. If the bore is less, then the valve size will be very compact. If the bore is more, the valve size will be more. This standard says what should be the minimum bore for each and every classes, each and every sizes. Larger than 32 inch, it refers to the table given in the standard, whereas it refers to 16.34 for all other sizes and all other pressure classes. Then clause 5.6 talks about the gate design. It says it could be a single piece wedge or a solid or flex wedge until unless specified by the customer. So it permits use of solid and flex wedge. It also says you can have a split wedge, two wedge. It could be either a split wedge gate or the parallel seat. Let's see where each type of valves are, the gates are used. Now, this is more popularly used in smaller sizes. Solid wedge is a single wedge type, is recommended for use in oil, gas, and is preferred for slurry and heavy liquids. It can also be used in steam services where the double or split wedge pose some chattering problems. Having said that, the solid wedge, it has got tendency to thermal binding. When you close a gate valve with wedging action, where in hot condition and allow it to cool, then what happens? The body contracts, and then it will have a binding on the disc. Okay, so that binding will lead to sort of a stem failure if you are trying to forcefully remove it. Okay, so this to overcome this only, people have gone in for other designs like parallel design or flex wedge. Okay, so this, what you see here on this is a flex wedge. The shape of the disc is similar to two wheels connected by a short axle. The axle is strong enough to hold both the wheels. Okay, the advantage of this is it can take off slight miselement. Both these wedges have a seat ring which is tapered, right? That's why it's called a wedge gate valve. So the seat rings are tapered, and for a perfect sealing, you need to have both seat ring and a wedge perfectly machined. The angle has to be perfectly matching. Otherwise, you will not have the sealing. So in case of large sizes, in case you expect some pipe deflections, this wedge gate valve will not take the minor misalignments, whereas the flexible wedge can take the misalignment. And also, it will not lead to thermal binding. You know, this is the advantage of this. The solid wedge can be used in any direction. There is no size, what do you call, orientation. Similarly, flex wedge also can be mounted in any direction. But when you have a split wedge, like what you see here, which has got a sort of a ball and socket seat, which has got independent seats. So this is the discs are free to adjust to the ceiling. Okay. Again, it will take care of a minor misalignment. These two seats are independent, and when you force it, you will have that seats disc are having contact with the seats. So this is sensitive towards the orientation. It's preferable to mount with the stem in a vertical direction. Then let's move on to the parallel or double disc gate valve. As the name implies, it consists of two independent discs, okay, and they are forced apart by a simple closure mechanism, a spreader mechanism, which is basically provided by a coil spring over here. Okay, it can take care of sort of a misalignment of the seats, either due to the pipe deflection or due to the thermal contraction on account of cooling. That's why this is very popularly used in high temperature applications. Having said that, now people do come back to flex wedge for high pressure application, high temperature application also. A simple fact that this flex wedge has got less number of components. You have a single piece wedge and then connected with a stem. Whereas here you'll have a number of components more, two disc, then coil spring, and then you have a arrangement to retain it, and a stem, and there is a connection. So people do prefer parallel slide over to prefer wedge over to parallel slide in power industries also. Similarly, in refinery also, now people have started specifying the parallel slide. The difference is that the parallel slide valves are position seated, whereas the flex wedge are torque seated. So we need to clearly understand the difference between those two things. Then we'll move on to the class on to guide rib and guide slots. The class 5.63 very clearly says body and gate shall have guide surface to minimize the wear of the seat during the operation of the valve, to accurately position the gate throughout the travel distance, to ensure alignment of the gate and stem in all orientation without gate binding or galling. Now the standard 13th edition also talks about the larger size, larger than 24-inch, the guide should be hard faced, so that even when it is mounted in horizontal orientation, it doesn't pose any operational issue. Having said that, let us also understand that larger size valves, when we are going to order, it is always better to inform the manufacturer about the orientation, particularly if you are going to have it in a horizontal orientation, so that he can take care of it in the manufacturing. So preferably, its orientation with stem vertical is always preferred. The orientation part, I just want to share with you the API 615, which talks about the guidelines for pipe refinery valves. It has, before even API 600 13th edition introduced a clause on the hard facing for larger sizes. This standard recognized that when valves are, large size valves are used in horizontal orientation, stem horizontal, it can result in the cock and lock syndrome, where the disc weight can hang against the body and cause a sort of damage during operation. So that's why I kept saying that larger sizes, when you are going to have a stem orientation other than the vertical, it is better to inform the manufacturer so that he can address that in the design, manufacturing, and testing. To give an example, A customer had ordered a 72-inch and 64-inch valve for a flare gas application and said that valve is going to be mounted with stem upside down. So we as a manufacturer took care in the design and the manufacture and testing and supplied the valves, which is working satisfactorily. On the other hand, another customer at the Middle East ordered a 42-inch valve and mounted in a flare gas line again, but at a different orientation like this, what you see here. And what has happened is this valve became inoperable, and when they tried to operate it, they got the stem bent. So that's why I said that orientation, though the standard says 24-inch and above, you need to have a hard facing. It is better to inform the manufacturer prior. Other clause on 5.8 talks about stem and stem nut design. What does the standard says? I just verbatim read out. The stem design shall be such that the strength of the stem to gate connection and the part of the stem within the fall pressure boundary shall under axial load exceed the strength of the stem at the root of the operating thread. A bit confusing. Let me put it very in simple terms. We all saw that wedge gate valve has got tendency to get sort of thermal bound. In case if the disc is jammed and if one tries to open the valve, and if the design is not such, it can fail here, like what you see in one of the competitor valves. It has failed at the bottom. Then what happened? The disc would be remaining in closed position, but you will see that valve, the stem is moving up, and operator may think that valve has opened, whereas the disc has it remained in the closed position. That is why standard says, if at all any failure should occur, it should occur outside the body bonded joint, so that visibly you can see the failure. So this is a typical case of LNT valves where we have designed, you will see the ample T-head, and the design is such that it will fail only outside the body bonded. So one has to look for these sort of clauses, compliance in the valves what you order. The standard also talks about what should be the wear travel allowance. You know, wedge gate valve, due to wear and tear, the disc can move down. And if a proper wear allowance is not there, then you are going to lose the life of the valve. So the standard very clearly says what should be the wear allowance minimum for each size. It is all tabulated, and it is up to the manufacturer to have a higher wear allowances. And this also sometimes reflected in the stem projections. So one can inspect the stem projection rather than the internals. It is difficult to inspect the wear allowance with the disc and the seat in position. There is another clause on the standard talks about design. The stem strength shall be considered when calculating the maximum input force from the hand wheel and gearbox if equipped in accordance with MSS SP 91. In accordance with the maximum drill pull specified by the purchaser. I just want to spend some time on this. This standard MSS SP 91 talks about the momentary force which is required for unseating and seating the valve. Many a times you will find the customer specification will specify a clause like this: maximum operator force required to seat or unseat the valve at maximum specified differential pressure shall not exceed 360 newtons. Okay, and sometimes some of the now we find that women operators are operating the plant, and there is a requirement to have a lesser effort. So there are specification which calls for 250 Newton. So what we have to remember in mind is that when a valve is to be operated, like a multi-turn valve, like gate valve, when during the 90% of the stroke, you don't need much force. You need only force to overcome the frictional forces which is happening between the gland packing. Only at the near closing or opening, you need a momentary force. So designing a valve to unseat and seat to 360 Newton will lead to higher size gear unit or a larger size hand wheel. And imagine if that compliance is to be ensured and select a gear unit or hand wheel larger, and in the actual practice, when there is a leakage of valve in the plant, what is the tendency of the operator? The tendency of the operator is to apply more force and arrest the leakage. But in the process, what happens? You damage the gear train. What you see here is a stem bend on a gate valve. which has been designed to comply to a particular standard. So that is why this standard API 600, though it is not specifically coming out, but it simply says that you can use MSS SP91. Okay, so it is very important when you specify, I think, incorporate that momentary force also into the specification. Section 5.9 talks about the packing and stuffing box. The standard says the minimum 5 packing. So people will ask, can I use more than 5 packings? But it has been found graphite packing systems, the combination packing, which is 3 die molded and top and bottom braided, gives an excellent performance. So it's enough if we need to have a 5 packing. It also talks about the shape of the packing. It should be square, or it can be rectangular or trapezoidal cross sections. And it talks about the surface finish, what is required to be given in the standard. One should not have a smooth finish. Otherwise, what will happen, that the graphite transfer will not take place and you will not have the sealing as effective as what you get. So optimum finish on the stem, optimum finish on the stuffing box is required. And lantern ring when required by the customer. This is a typical standard packing you have. And then lantern arrangement when it is required. What is the purpose of lantern ring? Lantern ring is to provide a further integrity to the gland packing. If there is any leakage through this, then you can prevent the leakage to the atmosphere by tapping off this leakage through the leak of connection here. Or you can provide a sealing fluid through this and arrest the leakage. And this arrangement is used for certain critical applications like in the nuclear industries, where the leakage to the atmosphere are limited. Of course, now with the modern best available sealing technology, there are good packing materials available which provides a good sealing across the temperature band. Okay. So when you come to the end user preference, the end user, most of the end users still prefer to use this, specify this combination, die molded and 2 braided end rings, whereas the best available sealing technology today is all fully braided construction. And we have seen in our test of API 624 Fujita emission that this type of packing has given an excellent performance. In fact, less than 50 ppm. And if you see, most of the end users allows only the molded and braided, whereas only few people allow fully braided as alternative. And one of the important change which took place in the 13th edition is that all the valves supplied to API 600 has to meet API 624 for fugitive emission. So this is a very important aspect. You all know that valves constitute a major portion in terms of emission to the atmosphere. And that's why the standard now talks about qualifying the valves. So you need to, earlier there used to be a packing qualification. API 622, you should use only 622 qualified packing to meet the requirement. But now the standard recognizes that not only the packing has to be qualified, but the valve has to qualify to meet that 624. So the standard talks about emission level of 100 ppm and less, and with no adjustment. Okay, so basically here I've got different combinations. Can API 624 compliant packing used for oxygen service? The answer is no. And similarly, steam service, no. They are designed for the refinery application and best suited for the VOC, highly hazardous gases. Then we move on to the operators. The 5.11 talks about operators. Until otherwise specified by the purchaser, the valve shall be supplied with hand wheel. There are different operators options are available which need to be specified. It could be a manual operator, it can be a power operator, and the gate valves are operated using pneumatic or electrical also. What you have to bear in mind while selecting the actuator is that ensure that linear speed of the stem is not exceeding 12 inch per minute. Okay, the reason being, we all saw there's a flex, this is a wedge, whether it is a solid wedge or flex wedge. When you close it very faster, it can lead to the jamming. So that is why when you use electrical actuator or pneumatic actuator, ensure that in case of electrical actuator, you can select an RPM so that it doesn't exceed that linear speed. you can exceed linear speed, may say up to 18 inch per minute by taking certain precautions in electrical actuation. In case of a pneumatic actuator, you need to specify that up to 80% that speed can be faster, and then the 20% closing should have a cushioning effect. So the actuator selection should be done based on the differential pressure, based on the media, based on the frequency of operation, and the type of factor of safety is required. Okay. So now let's move on to 6.2, the trim. Trim is nothing but a collective term for internal parts which are wetted, which sees the effect of the flow media. So if you take API 600, it lists down stem, body seat surfaces, wet seat surfaces, and back seat as the trim material. And it is all listed out. There are about 29 trims in the standard API 600. Example, you take a trim 5. When you specify trim 5, what does it mean? The stem material should be 13% chromium. The seat surfaces should be hard-faced. The wet surface should be hard-faced, and back seat should be hard-faced. This is the meaning of the trim number 5. So if you say trim 10, what does it mean? The stem material should be 316. The seat surface and wet surface should be 316. Back seat should be 316. The standard also allows certain alternate trim numbers. Many times people say that trim 316 doesn't give continuous leak tightness. After a few operations, it scratches. So people would suggest trim 16 or trim 12. So now the standard allows alternate trims. Trim 16 is what? Both are hard face. On a stainless steel base material, hard facing is done. Now hard facing is what? The standard says it could be a cobalt based alloy, it could be a stellite, stellite 12 or stellite 21, or it could be a nickel based alloy. All these things are covered in the standard, and depending upon the application, the service media, one would select the trim material. And again, the stellite, there are 3 categories, 3 grades available, 6, 12 and 21. Depending on the hardness requirement, one would select the stellite. The standard also talks about bypass auxiliary connections. It is very clearly where should have the bypass. Generally use a bypass in a gate valve for 2 purposes. In steam services, to warm up the line before opening the main valve. In high pressure, you need to balance the both sides so that the valve becomes easy to operate. The standard very clearly tells what should be the main valve size and what should be the bypass valve. Then the standard goes on to define what are the requirement for testing, marking, and preparation. Quickly, let's see one by one. Class 7.0 talks about testing and inspection and examination. So visual examination, you should test the valve visually for any damage. You should check for legibility of markings, what is given in the casting. You should also check the documents. And the valves have to be tested as per API 591. Since it is all metal seated, the standard allows some amount of leakage. But in L&T valves, as a company policy, we have been using zero leakage. And only at the time of offering to the third-party inspector, if the leakage is not zero, it is slightly more. But within the limit of 598, we use the API 598 criteria. So the standard really tells very clearly what should be the test media, what should be the chloride content in what should be, how many pressure gauges you should use. All those things covered in the standard. The marking, the standard also tells what should be the marking on the nameplate. It says apart from the requirement of 16.34, you should also have API 600 if you are going to comply to this. It talks about the body material, stem, disc, and whether the disc faces and the other manufacturing details like serial number and date. So serial number is very important for tracing the documents of the valve. And then the marking, it is important sometimes, unidirectional valves have to be marked, and also while installing the valve, you need to take care of those things. Otherwise, the valve malfunctioning will take place. Class 9 talks about the valve preparation and shipment, and it very clearly says the requirement. You should protect you with the wood, fiber, plastic or metal, and also says very clearly cover shall be designed so that the valve cannot be installed without removal of the protective. It takes so much of attention on these things. And this is how a valve will be seen protected at the manufacturer end. On the other hand, we have seen at customer end, the valves are lying like this without any protection. What is the implication of that is the foreign particle can ingress into the seat area and cause a damage to the seat, and thereby it can lead to the leakage even before the valve is installed in the line. The standard 9.3 also says very clearly what should be the position of the gate while it is shipped. It says a gate valve has to be shipped in a disc closed position. Similarly, a ball valve standard, if you take, it will say ball valve has to be supplied in an open position. So this is basically to protect the seating surfaces. The packaging, the standard also tells very clearly how you need to do the packing. And what you see on the right side is a valve which is opened up at the site before the installation, and see the condition of the valve. And I'm sure once it is installed in this condition, it's going to leak. So the standard very clearly gives all the requirement, and it is very important people at the manufacturing end as well as the user end to understand the intent. Now let's quickly see some of the applications of the variants. The gate valves can be used for oxygen service. All you need is you need to have a different material, and you need to do the cleaning of the valve internals in a clean room, and then use a BAM certified gaskets and packings, and then supply in a fully sealed cover. And the cryogenic valves, again, they are all evolved around the API 600 standard, but there's another standard which talks about the extension and other things. BS 6364 is the standard for the. So what we saw was a lot of glimpses of various saline features of API 600, how a manufacturer has to take care of it, how end user has to understand the clauses and then maintain them in their valves. So now there are a few glimpses of valves manufactured by L&T, 64-inch class 150, 42-inch class 600, 18 tons, and then 27 tons, 60-inch class 300 valve. And this slide shows a glimpse of the L&T valves product folio. We have, as I told you, a wide variety of products. So with this, I end the presentation.